Space is slowly filling up with junk. As demonstrated on February the 10th, when a defunct Soviet-era Russian spacecraft collided with an American communication satellite, orbiting debris is becoming an increasing problem for spacecraft operators. Of the 6,000 or so satellites launched since Sputnik in 1957, only about 800 are currently active. Earth is therefore orbited by a huge number of disused spacecraft, as well as fragments formed when they explode or break up, and the discarded objects used to launch them, such as rocket stages. Space debris poses a serious threat to both space operations and, in the case of manned spaceflight, human safety. A chunk of metal only 10 centimeters in diameter could do untold damage to a spacecraft such as the International Space Station. For these reasons, the European Space Agency has a team at its operations center in Darmstadt, Germany, dedicated to monitoring debris and giving advance warning for operational ESA satellites.
Our current information sources, the major information source, is from the US Space Surveillance Network. They track anything which is up there larger than 5 to 10 centimeters in low Earth orbits and larger than 30 centimeters to 1 meter in the geostationary ring, which is about 35,800 kilometers away from us.
ESA is also a founding member of the Interagency Space Debris Coordination Committee, which brings together 11 space agencies from around the world to tackle the problem of space debris. The committee's goal is to take active measures to preserve the space environment for future users.
Currently, people concentrate on reducing the growth rate of the current space debris population, and this is best done, first of all, by not launching as many objects into space, particularly the ones which are not useful, that is mission-related objects. The second measure is reduce explosions in space. This is, for instance, done by performing burns of the engines to get rid of the remaining fuel, which otherwise could explode. A second possibility is what's called space debris remediation, that is really curing the problem, and that is done by taking mass from orbit, and this you do by, at the end of the mission, deorbiting your satellite, which will then most likely burn up in the atmosphere.
ESA has also begun to acquire its own methods of detecting space debris, which will be combined with US readings as scientists painstakingly continue to build a space debris database. A powerful European telescope is already employed for these purposes.
ESA's Space Debris Telescope is a 1 meter size telescope, a very sensitive telescope that is located in the optical ground system in Tenerife on the Teide Mountain in 2,400 meters altitude. Its role is to observe the geostationary ring and to detect objects of very small size. It is sensitive enough to see objects of just 10 centimeter diameter.
And given the scale of the threat to the space environment, ESA hopes to expand upon these monitoring capabilities.
The ESA Space Debris Telescope can detect and follow up objects, so it has the capabilities to determine orbits of space objects accurately and maintain objects in a catalog. But in order to achieve a full coverage of objects in the geostationary ring, more than one telescope is required. To achieve this, we need a network of at least 3 telescopes well distributed in longitude.
The build-up of hazardous space debris is a situation that can be responsibly monitored and managed. With the combined efforts of the global space community, incidents such as February's collision can be avoided, or at least kept to a minimum in the future.